Okay, today let's talk about PARCA Clinical Section 4.2. 4.2 covers collimation, scatter, shuttering, and grids. So, collimation. Proper collimation is critical to achieve optimal image quality. Collimation limits the X-ray beam to the anatomy to be exposed. So, here you have the X-ray tube, and bolted onto it just below it is a box called a collimator, and it has 4 lead plates. And you can move these lead plates so that they move together or apart and same side to side. And so you can use those lead plates to narrow the beam so that just the anatomy you want to expose gets radiated. So let's say you're taking an ankle x-ray. You want to bring those blades in side to side and top to bottom so you're only exposing the ankle and not the whole foot. So that's what a collimator does. Scatter radiation. Scatter radiation can be reduced through proper collimation and using a grid. So here is the X-ray tube, and here you have the primary beam coming out here, and it encounters the patient, and some of that radiation is going to go into the patient and be scattered out the sides. The scatter can also reach the detector, so this ray here might come in this way and bounce off and go way over here and hit the image receptor over there. And we'll talk about how to fix that in a minute. The radiation that travels through the patient comes out the other side, headed for the image receptor or image detector, is called the remnant radiation. So you have primary beam, scatter radiation coming out the side, remnant radiation going to the detector. And this is where the grid comes in. Grids are placed between the patient and the detector to reduce the scattered radiation reaching the detector and thus improve image contrast. So here you have the grid. A grid is made of metal. It is lead strips to block the radiation, and they're angled like this, and then it has usually aluminum spacers between the lead strips. So here you have the X-ray tube, comes down, hits the patient, and these scattered ones that come out at weird angles will be caught by the grid, and ones that go straight through the patient and on through the grid will reach the detector. And so if you didn't use a grid, you'd get this sort of flat gray image that's not very sharp, whereas if you use a grid, you don't get all that extra scatter radiation, and everything is high contrast, black, white. You don't have many shades of gray in this image. So that is what a grid is used for. Shuttering. Shuttering blocks part of the image on an electronic screen. It's a post-processing activity. So the best way to think of shuttering is cropping. As you might crop a digital photo, shuttering works like that, but it's important to remember that it's done after exposure. So here's a good example of shuttering. So on the right-hand side, you have the original image, and it has 4-sided collimation. So we can see that the collimators were brought in to this ankle, and it has collimation on all 4 sides, which is good. You want that for radiation protection, but it makes it sort of hard to look at the image with this ugly white border around it. So after the image is taken, then you would bring in shutters, right? You would crop the image so that white border is gone, and now this is a much easier image to diagnose. You can see the heel bud much better in the shuttered version. So that's creating a presentation state, we would say, right? So that's post-processing to create a presentation state so that you're presenting a much better image to the radiologist. And that is all about 4.2. Thank you for watching.